Okay, so this is the fourth video on this problem type. The first one explains the idea behind it, so I highly recommend you watch that one first if you haven't. The second one is just an extra example that's the same as the first, but with different numbers. The third one is a little different if you're uncomfortable with negatives, so that might be a good one to watch. And this one is going to feel different. So the question is, find the vertex and axis of symmetry of quadratic function y equals x squared minus 6x plus 9. And if you watched the Understanding Parabola, Vertex, and Axis of Symmetry by Graph and Table of Points videos, this is example 2 from that video. The reason why I keep telling you which example it is from that video is because if you're looking to understand the reason behind things and to make connections, you can go back and see how the graph of this function relates to the vertex and the axis of symmetry by algebra. All right, so this is a quadratic function. The reason it's a quadratic function is because it has it's a polynomial with the highest exponent being x squared. And when you graph it, it's going to be a parabola. So we're looking for the vertex and axis of symmetry of a parabola graph. So the quadratic function is this. Okay, so step 1 to finding the vertex is going to be to set this equal to 0, find the x-intercepts. And to do that, you're going to set this equal to 0 and you're going to factor. So that's going to be two things that multiply to a positive 9 but add to a negative 6. So then 3 times 3 is 9 and adds to 6. Make them both negative to add to negative 6. Because this is a 1x squared, I can just shortcut to saying the first two things that multiply to x squared are x and x. The last two things that multiply to 9 are negative 3 and negative 3. And if I multiplied it out, x times x is x squared, x times negative 3 is negative 3x, which is not this. But if I do negative 3 times x, that's another negative 3x, which then would form a negative 6x. And then negative 3 times negative 3 makes that positive 9. So I did factor this correctly. Notice that this is the same exact factor, x minus 3. So x minus 3 is going to get me an answer of x equals 3. And this is also going to get me x equals 3, which makes this a double root. So anytime you have a double root, it means that x equals 3 twice is the same answer twice, which means you only actually have one x-intercept, and it's 3, 0. If you want to think of it that way, you can say this is the only x-intercept, or you can say that there are two x-intercepts of 3, 0, and 3, 0, which really, when you graph it, only is this one graph. It doesn't look like 2 points, it looks like only one. If I were to graph this, and if you were to look at the previous example and to see it done in detail, it would look like 1, 2, 3, 0 is the vertex, and it looks something like this, which means that the parabola only hits the x-axis once, so there's only one x-intercept. That means that that's only going to happen under one condition, which is, I'll show you in just a second. So step 2 for the algebra is if I add the two x-intercepts, well, I only really, step 2 is really to find the x value of the x-intercept. So let me just write that down, x value of x-intercepts. It's really just 3, but you can write 3 and 3 twice if it makes you feel better. Now step 3 is to add these and divide by 2 to find the exact midpoint of these 2 points, because the vertex is always in the smack middle of the parabola. Well, if I add these and divide by 2, I get the same answer. 3 plus 3 is 6 divided by 2 is going to be 3, because smack in the middle of 3 and 3 is really just 3. So if I have a double root, it's always going to be because that root or that solution is the only x-intercept and the vertex is actually on the x-axis at that point. So that means that my x value here for step 3 is 3. My y value, I haven't solved for algebraically, but you should be able to guess it if you understood what I just said right now, okay? So see if you can figure that out. You can pause the video if you need. That being said, if you don't figure it out and you just want to make sure or double check, you can always use step 4. So I'm going to do that, which is to plug this value into the original equation and solve for y. the algebraic way. So 3 squared minus 6 times 3 plus 9. So 3 squared is 9, minus 6 times 3 is 18 plus 9. 9 plus 9 is 18, minus 18 is 0. So if you guessed 0 for this because it was a double root, then you were correct. So if you get a double root, then you've basically found the vertex right off the bat if you understand that fact. Otherwise, you can go through all the algebra steps and it will still give you the correct answer. All right, so the vertex we found was 3, 0. We found it algebraically and a little bit more intuitively. And the axis of symmetry is still x equals the x value of that vertex. So that's my answer. All right, so one more example, last one but not the least, is example 1 from the understanding vertex and axis of symmetry by graph and table of points, which was our parent graph, y equals x squared. So this is the most basic parabola graph, and I'm still finding its vertex and axis of symmetry. All right, so for step 1, it's to solve by setting this equal to 0 and finding the x-intercepts. Now, you can factor this if you want to do it that way. So x squared is going to be x times x equals 0, and then that's going to give you a double root of x equals 0 twice. Because there's really no other number part of this expression except for the x squared, so there's no other terms like minus 6x or plus 9 to factor it, you could also do it the old-fashioned way, which is to get rid of the square and square root both sides. And don't forget that there's always 2 square roots to every number, so it's a plus minus, so then it's going to be x equals plus minus 0. Now, this is actually the only exception to what I just said, which is that every number has 2 square roots, because a plus 0 and a minus 0 is really 0, and that is 0 is the only number in the real number system and even the complex number system where that works out like that. So I still get the same answer as I did by my little pseudo factoring here. So step 2, find the x-intercepts. By the way, you can skip step 2, 3, 4 algebraically if you already know the answer to this. Because, of course, if x equals 0 for my x-intercept, then my x-intercepts are 0, 0. And if you want to write it twice, 0, 0. So step 2 is finding the x value of these x-intercepts, which is 0 and 0. Step 3 is find the average, so 0 plus 0 divided by 2, which is 0. So then my vertex is going to be 0, and then I don't know this number unless you intuitively figured it out already at this point. So if you have, or you need a second to think about this, you can pause the video at any point to think about that, see if you figure out the answer before I do the algebra. Okay, so I'm going to do step 4, which is to plug this in to the original equation and solve for y. So y equals 0 squared, which is 0. So if you guessed 0 for this point, you were correct. The vertex is 0, 0. The axis of symmetry is x equals 0. And hopefully that's enough examples for you to figure out a lot of things, or try things at least and ask questions later.